Okay, so here's part C.
Yeah.
All right, you can have the marker for this one,
So-
and you can do anything you want. You don't have to follow. You don't have to follow. If you have a different idea, you can do whatever you want.
We're going to. You said you start inviting 3 first.
2. We were gonna stay at 2, and then we were gonna invite 11. We were gonna do the same thing we started doing. 2, 3, and 4.
2, 3, 2, 3, and 4.
And then that crossed out everything up to 9, I think.
That was that. Yep. And then this was. I think this was 8. Oh, so it was 9.
And then we were gonna we were gonna go to 11.
11
and not.
first?
Yeah.
So you have 11. So you don't know what happens to 10. And then, so 11, you can't invite 14, and you can't invite 16. So you go to 12, and 15, plus 5 is 17, and 13. You can't invite 10, and then you can't invite 18. And then 19 and 20. But we lost one here. We got 8.
So from shifting 1 over, we inadvertently shifted this one over.
Ah, okay. Interesting. So what do you think now?
Well,
So maybe I'm thinking the optimal number is 9.
Okay.
Because
Well-
whenever you seem to shift 1 over, it seems to shift everything over. And
Right, and how would you describe this strategy in relation to the original greedy algorithm strategy?
well,
it's worse.
yeah. It doesn't produce as many people you can invite.
Sure, that's the result, but tell me about the strategy here.
Well, you started at 2.
Uh-huh.
Then once you completed that set, you decided to choose the next one up from the first one you could. So once you completed the 2, 3, 4 up to 9,
Uh-huh.
you didn't want to choose the first possible one.
Okay.
You choose the second one.
All right.
And then that caused you to, then everything else basically was forced.
Interesting.
Yeah.
All right.
So it seems like this greedy strategy is working the best for us
Okay.
in this case.
Yep.
But is there any way? No, I don't think there's any way to like pull it back because we're sort of pushing it forward right now.
Right. So this modification that you've tried this is still very similar to the greedy algorithm.
Yeah.
Very similar. But it pushed things forward, and that caused fewer people to be invited.
And you can't pull things back because these groups have to be separated by a minimum of 5.
Okay.
No.
What do you think?
So I was just thinking what would happen if we inverted everything. Like if we started with 5, 6, and 7, like all the people that were not invited, if we tried to invite them and see what happens, and all the people we were planning to invite we didn't invite,
Uh-huh.
and we could see which people we couldn't invite.
Okay, so you think the sort of opposite. Let's invite the people that we weren't inviting.
Yep.
Because we could only ever get to 9.
Yeah.
And maybe if we look at the people we couldn't invite, maybe there's a way to do, in that case it would be 11. That's a great idea.
Oh.
All right, let's take a look.